Good evening, everyone. Good evening, good evening, good evening. I welcome you all again to the NEET Elite. Hope all of you are doing great, having the good time at home. Well, people, if I'm audible and visible to everyone, hit the chat box with the thumbs up. Let me know if I'm audible and visible to everyone fast. Yes. Let me know in the chat box if I'm audible and visible to everyone. Yes, Yashwant has come up with the code. The code is too big, Yashwant, and the chat is running too fast. I cannot read it, bro. If I'm audible and visible to everyone, hit the chat box with the thumbs up. Let me know fast. Yes. Okay, wonderful. Hi Khushi, hi Angela, hi Farooq, hi Shaista, hi Students Choice, hi Fatima, hi Khushi, hi Obi, hi Sayed. Hi Tariq, hi Yasin, hi Gayatri, hi Zahid, hello Snehal, what's up? Alright, Walaikum Salam Babar, Walaikum Salam. Hello, Walaikum Salam, Farkhanda, Walaikum Salam. Alright people, alright. As you all must be knowing, today we are starting with a new chapter, which is what we call as redox reactions. Yes, or you call it as the mole concept part 2. Yeah? We are done with the mole concept, right? And now today we are going to start the new chapter, which is what we call as redox reactions. Yes. So let me know in the chat box if you guys are super duper excited for the session. Let me know in the chat box if you guys are super duper excited for the today's session. Yes. Let me know fast. Let me know fast in the chat box. Yes. Zahid seems damn excited about the session. Asan is saying teaching is the one profession that creates all the other professions. Absolutely, yes. Yes. Snehal is saying mistakes are sign that means that you are trying something new. Yeah, exactly, Snehal, you're right. Absolutely. Okay. All right. Yes, Yojana, I'm in Srinagar, Jammu and Kashmir. Exactly. Right now, the temperature over is -2 degrees centigrade. Yeah, believe me. Yes. Yes, people are super duper excited about this session. Yeah. Yes, Janan, exactly. Exactly, Janan, exactly. Yeah, exactly. Alright, so before starting the session, let me introduce myself. As you all must be knowing now, my name is Wassim Sir and I'm your chemistry master teacher right here. Yes. So people, before starting the session, do not forget to like the video, share and subscribe the channel so that everyone will get benefited out of these sessions. So do like the video, share and subscribe at the same time so that everyone will get benefited out of these sessions, which I always say in the every session. Yeah. Alright people, so before getting started with the redox reactions, I need to give you the brief introduction about the Vedantu NEET Pro subscription. What all benefits you guys are going to get if you'll enroll yourself in this Vedantu NEET Pro subscription. Let me tell you guys are going to get 5,000 plus hours of live online teaching. Regular tests and assignments will be provided to you, which contains more than 10,000 questions. We have got 20 plus teachers with 5 plus years of experience will be personally mentoring you for the upcoming NEET 2021 as well as 2022. And you have got the complete option to learn either in English or in Hindi. It's completely your wish to select the language, get trained by the master teachers of Vedantu in your physics, chemistry and biology for the upcoming NEET 2021 as well as 2022. Yes. And people, at the same time, over here, we are going to cover everything which includes your micro as well as crash courses. Yes. For the ones who are going to appear in the NEET in 2021, we have come up with 3 different plans and people, you can see on every plan right here, we have got 50% off. Okay, that's actually immense. Yes, the 1 month plan after the 50% off, you guys are just getting it for 3.75k. 3-month plan, you guys are just getting it for 11k. 6-month plan, you guys are just getting it for 29k. And guys, let me tell you, this offer, this 50% off is just valid between 20th to 27th of December, right? So do not forget to get enrolled in the actual batches, get trained by the master teachers of Vedantu personally on the actual Vedantu platform, right? For the ones who are going to appear in the NEET in 2022, again we have come up with 4 different plans, and on every plan right here, again you have got 50% off. Yes, 1 month plan, you guys are just getting it for 2,500. That's it, guys. Yes, you are getting it for 2,500, right? So I want all of you to give it a try, at least for 1 month plan. Then if you really liked it, if you really like it, then you can join the better plans as well. Yeah, longer plans as well. Yeah. 3-month plan, you guys are just getting it for 6.75. 6-month plan, 14K. 12-month plan, 32K after the 50% off. And all these discounts are valid just between 20th to 27th of December, right? And at the same time, guys, for the droppers, again, we have 3 different plans. As you all can see, 1 month, 3 months, 6 months. On every plan, again, you have got 50% off right here. Yes, and 1 month plan after the off, you guys are just getting it for 4.5K. 3 month is 15.5, 6 month is 41K, right? And this 50% off is just valid in this week, guys, 20th to 27th of December. Yes, now the point is how to get enrolled in the long-term batches, how to get enrolled in the actual Vedantu platform through these plans. Let me tell you, there is a link in the description box of the video. Just click on that link, use the coupon code as what? WSPRO. On using this coupon code of WSPRO, you guys are going to get the 50% off in whatever plan you're selecting for yourself. Yes, so hurry up, get enrolled in the actual batches, actual long-term batches, right? Get trained personally by the master teachers of Vedantu in your physics, chemistry, as well as biology, right? So people, yeah. Are you guys super duper excited for this session? Let me know in the chat box first. Let me know in the chat box if you guys are super duper excited for this session. Walaikum salam, Sadia. Welcome. Welcome, welcome, welcome. Thank you, Snail. Thank you. Josh is high, Sayyid is saying. That's wonderful. Yashwani says army is back. Wonderful, Yashwani. That's great. Thank you, guys. Thank you. Thank you. Yes. Let's get started with the redox reactions. And people, in the today's session, I'm going to cover your basics of the redox reactions, which includes your oxidation state, rules to calculate oxidation state, and we are going to see some structures which are really important in order to calculate the oxidation states of different elements in a compound. Yes? Thank you, Afra. Thank you, thank you, thank you, thank you. Wanakam Shiva, wanakam. All right, guys. All right, all right. Class end time is 12. Yeah, it's exact 12. I might take few minutes extra today because we have got a lot of things to discuss in the today's session. Yeah, so it might end at 12:15. Yeah. Okay. So people, let's get started with the first term which we have to discuss right here. That's what we call as oxidation state. That's what we call as oxidation state, right? What is oxidation state all about? What do we mean by the term oxidation state? Let me tell you, as per the definition of it is concerned, the charge present on an element in a given compound is what we call as oxidation state. The charge present on an element in a given compound is what we call as oxidation state. And people, the charge present on an element in a given compound, it can be real or virtual. It can be real or virtual. Now the point is, what do we mean by this real charge? What do we mean by this virtual charge? How can we actually visualize this oxidation state concept right here? First thing, I want you guys to remember the definition. Oxidation state is nothing. It is just the charge present on the element in a compound. Yes, and the charge can be real or virtual. Now the point is, what is this real charge and what is this virtual charge right here? Okay. See guys, have a look. First of all, if I'll talk about the ionic compounds. In ionic compounds, the charge present on the element is the real charge. What do we mean by that? See guys, first thing you're supposed to remember right here, for ionic compounds, in case of the ionic compounds, the charge present is real, it's not virtual. Yes? What do we mean by this real charge right here? See guys, have a look. For example, I'm taking one ionic compound NaCl right here, okay? First of all, let's see how this NaCl was formed. How this NaCl was formed. How this NaCl was formed? As you all can see, this NaCl is made up of 2 elements. One is your sodium, one is your chlorine. Sodium has got strong tendency to lose the electrons, so sodium would have got converted into Na positive and it would have lost 1 electron. Now chlorine at the same time, it would have gained the same electron which was given by the sodium, and chlorine would have got converted to Cl negative, right? So people, over here I got the cation and the anion. I got the positively charged species, I got the negatively charged species. Can I say there will be force of attraction between these two species, right? Because the charges present on them are opposite, and we call this force of attraction as the electrostatic force of attraction. Yes, there is the electrostatic force of attraction between this cation and the anion. And people, let me tell you, this electrostatic force of attraction between the cation and the anion is what we call as ionic bond. And any substance in which we have got ionic bond, we call that substance as the ionic compound. Yes, very simple, correct? Now people, have a look. Sodium is actually present in this compound in the form of Na positive, and chlorine in this compound is actually present in the form of Cl negative, right? So talking about this NaCl right here, on sodium you have got +1 unit of positive charge, you have got -1 unit of negative charge over here on chlorine. And as per its definition is concerned, the charge present on an element in a compound is what we call as oxidation state. So I can say sodium right here has got +1 oxidation state, chlorine right here has got -1 oxidation state. And people, let me tell you, these are the actual charges present on the atoms. These are the real charges, actual charges which are there on the elements due to the complete transfer of electrons, So remember, in case of ionic compounds, due to the complete transfer of electrons, the charges present on the elements, these are real charges, these are actual charges, right? Very simple. Yes. All right. Moving on to the covalent compounds. I told you the charge present on the element, it can be real or it can be virtual. Real charge is possible in case of ionic compounds, and virtual charge is present in your covalent compounds. Yes, Janan, I'll be teaching titration here too in this chapter. You just wait for it. Yes, that is going to be our 3rd or 4th session, yes, in which I'll be teaching you titrations. All right. Now, I told you guys, the charge present on the element, it can be real or virtual. Real, it can be in case of the ionic compounds, and virtual, it can be in case of your covalent compounds, okay? First of all, covalent compounds are the ones in which you have got covalent bond in between the atoms, right? Let me take the case of water right here. If I'll talk about the structure of water, this is going to be the structure of water right here, correct? Now people, in case of covalent compounds, there will not be the actual charge present on the atoms. There will not be the real charge present on the atoms. Real charge will be only present on the element if there is the complete transfer of electron. But over here, in case of covalent compounds, there is not any complete transfer of electron. There is the mutual sharing of electrons, okay? Then how come charge exists on these atoms over here in the covalent compound? That's what we have to check right here. Yes. First of all, as you all must be knowing, in your periodic table, we consider fluorine as the most electronegative element, followed by oxygen, followed by nitrogen, followed by chlorine, and so on. Yes, fluorine is considered as the most electronegative element, followed by oxygen, followed by nitrogen, followed by chlorine. That means if fluorine is the most electronegative element out in your periodic table, I would say fluorine has got more tendency, to attract the bonded pair of electron towards itself. Yes, it has got more tendency to attract the bonded pair of electron towards itself. Yes. Now people, over here in this compound, there is no complete transfer of electron. There is the mutual sharing of electrons. Because due to the mutual sharing of electrons, we get a covalent bond. Yes. Now people, due to the electronegativity difference between the atoms, there will be some partial charges present on the atoms. Due to the electronegativity difference, there will be some partial charges present on the atoms. How come? Have a look, guys. See, first of all, this is one single bond which I'm representing by this solid line right here. And this single bond is first of all made up of 2 electrons. 1 electron is given by oxygen, 1 is given by hydrogen, as you all must be knowing. So I was expecting, since this is a covalent bond, and as per the classical definition of covalent bond is concerned, there is the mutual sharing of electrons between the atoms. Yes. Now, first of all, I was expecting this electron pair to be at the center. But what I observed was, I observed this electron pair was slightly shifted towards oxygen. The electron pair was slightly shifted towards oxygen. Why is that? As I told you, oxygen is more electronegative than hydrogen. Oxygen has got more tendency to attract the bonded pair of electron towards itself. If oxygen has got more tendency to attract the bonded pair of electrons towards itself, so I would say the bonded pair of electron will lie closer towards oxygen. And when the bonded pair of oxygen will lie closer towards oxygen, oxygen is going to get slight negative charge, or we call it as delta negative charge, right? And hydrogen at the same time will get delta positive charge. This delta negative charge, it represents that electron density, sigma electron density, I must say, it is more towards the oxygen. Yes. At the same time, guys, we have got one more bond between oxygen and hydrogen, which is again made up of two electrons. One is given by oxygen, one is given by hydrogen. And I was expecting this electron pair to be at the center. Why I was expecting that? Because it's a covalent bond, and in case of covalent bond, there is a mutual sharing of electrons. But what I observed right here, I observed this electron to be more close towards the oxygen, due to which this oxygen again got slight negative charge. At the same time, hydrogen again got slight positive charge. Yes. So people, first thing, these are not the real charges present on these atoms right here. These are the virtual charges. These are the charges which appear to be present on the atom due to the electronegativity difference. Yes. Very, very, very simple. Now people, if I'll ask you, in case of your water, what is the charge present on this hydrogen? It's slight positive. So I would say its oxidation state is +1. Okay. What about this hydrogen? Its oxidation state is +1 right here. What is the charge present on this oxygen? It's minus delta, that means -2 delta. So I'll say its oxidation state right here is -2. Very, very, very simple. Yeah. But remember, these are not the exact actual charges. These are not the real charges. These are the charges which appear to be present on the atom due to the electronegativity difference between the atoms. Yes. Now people, at the same time, if I'm considering this carbon dioxide, as you all must be remembering the structure of carbon dioxide, it's somewhat like this, if you remember. Yes. Now people, have a look on what I'll be doing right here. I'm talking about the basics of it, okay? Yes. See guys, first of all, if I'm considering one bond between carbon and oxygen, this one bond between carbon and oxygen, which one is more electronegative? Carbon is less electronegative than oxygen. Yes. Or I can say oxygen is more electronegative than carbon. So I would say this bond pair of electron will be towards oxygen, due to which oxygen will get delta negative charge. Carbon at the same time will get delta positive charge. Yes. Now people, at the same time, talking about this bond, even this bond pair is going to be closer towards oxygen, due to which oxygen will get slight negative. At the same time, carbon will get slight positive. Now talking about this bond, oxygen is more electronegative, so oxygen will get slight negative, carbon will get slight positive. And talking about this bond, oxygen will get slight negative, carbon will get slight positive. If I'll ask you, are these the real charges present on the atoms? These would have been the real charges present on the atoms if there was complete transfer of electrons. But right here, there is no complete transfer of electrons. So it is going to be, these charges are going to be the virtual charges. These appear to be present on the atom. These are not the actual charges. These are the charges which are there on the atom due to the electronegativity difference between the two atoms over here. Yes. So if I'll ask you, what is the net charge present on this oxygen? It is going to be minus delta, that means -2 delta. So I would simply say its oxidation state over here is -2. What about the oxidation state of this carbon over here? Plus delta, that means I'll say its oxidation state is +4. What about the net charge on this oxygen? It's going to be -2 delta. So I'll say its oxidation state is -2 right here. Yes, I'm sure you are clear with the basic concept of oxidation state. It is nothing. It is the charge which can be real or virtual present on the element in a given compound. Yes. Yes. Let me know in the chat box if it's clear to you fast, so that I can move ahead and talk about the rules to calculate the oxidation state. Let me know fast. आसन कोऑर्डिनेट बॉन्ड भी बताया जाएगा. वेट करो यार, अभी तो स्टार्ट किया बस. Yes. All right, wonderful guys, wonderful. Let's talk about few rules related to how the oxidation state of an element in a compound is calculated. Yeah, let's talk about that. See guys, the first rule which I want you guys to remember right here is the oxidation state of an element in its standard state is taken as 0. the oxidation state of an element in its standard state is taken as 0. Let me first of all tell what this standard state is all about. If you remember, in the thermodynamics also we have discussed about the standard state, right? So over here I'm again going to give you the brief idea about what are the standard states, right? Standard state of an element is that state in which the element exists in the nature, right? For example, if I talk about oxygen, let's say I've got oxygen. If you all must be knowing, oxygen in nature exists in the form of O2 gas. Nitrogen in nature exists in the form of N2 gas, right? Fluorine in nature exists in the form of F2 gas. Yes, iron in nature exists in atomic form in Fe solid. Similarly, zinc exists in atomic form, zinc solid. Copper exists in atomic form, copper solid. Yes, these are some standard states of the elements in which the element exists in nature, right? Your oxygen exists in the form of O2 gas, nitrogen N2 gas, fluorine F2 gas, iron Fe solid, zinc Zn solid, copper Cu solid. Yes, and remember guys, whenever the element is going to be in its standard state, its oxidation state is taken to be 0. Its oxidation state is taken to be 0. So remember, from now onwards, whenever the element will be present in its oxidation, in its elemental state, standard state or native state, yes, we call this standard state as elemental state as well. We call this standard state as elemental state as well, or we call it as native state as well. That state of the element in which the element exists in nature. Yes? Yes? Very, very simple. So remember, whenever the element will be present in its standard state, native state, elemental state, its oxidation state will be taken as 0. Number 1. Okay? Yes, Harish, I'll be making the strategy video soon, bro. Just wait for it. Alright, moving on to next one. Moving on to the next one. People, you would be knowing about the group first and group second elements. Group first elements are what we call as alkali metals. Group second elements are what we call as alkaline earth metals, right? And as you all must be knowing, in your alkali metals, there is only one electron in the outermost shell, and in your alkaline earth metals, there are 2 electrons in their outermost shell. Yes, so people, alkali metals, they have got strong tendency to lose this 1 electron. So all your alkali metals, they show +1 oxidation state, because when the element loses the electron, it gets converted to the cation having the positive charge on it. For example, lithium, when it loses 1 electron, it gets converted to Li positive. Sodium gets converted to Na positive. Potassium gets converted to K positive. Remember, your group first elements, they have got 1 electron in the outermost shell, so they easily lose this electron and +1 charge comes on them. So remember, your group first elements, they'll be always present in +1 oxidation state. And at the same time, your group second elements, they have got 2 electrons in their outermost shell, so they easily lose these 2 electrons right here. And when these elements easily lose these 2 electrons, they get the positive +2 charge on them, which is their oxidation state right here. So remember, your group first elements, they'll be showing +1 oxidation state. Group second elements, they'll be showing the +2 oxidation state. Yeah? Yes? Exactly. This was the rule number 2nd. Rule number 3rd. Talking about hydrogen. Remember guys, whenever hydrogen will be attached to more electronegative element than it, okay? Whenever hydrogen will be attached to more electronegative element than it, the oxidation state of hydrogen will be taken as +1. For example, if you take the case of HCl, if you take the case of HF, if you take the case of NH3, right? If you take the case of NH3, in all the 3 compounds, in all the 3 molecules which I took right here, hydrogen is attached to more electronegative element than itself. And remember, whenever hydrogen will be attached to more electronegative element than itself, I would say hydrogen will always have the oxidation state of +1 at that time. Yes, very, very, very simple. Yes. Now people, at the same time, see guys, see, understand one thing. See, first of all, this is a single bond between hydrogen and chlorine, right? Now, chlorine is more electronegative than hydrogen, so chlorine has got more tendency to attract this bonded pair of electron towards itself, due to which chlorine will get slight delta charge. At the same time, hydrogen will get slight positive charge. Yes, if I'll ask you what is the oxidation state of hydrogen over here, you should say +1. If I'll ask you what is the oxidation state of chlorine right here, you should say -1. Absolutely, yes. At the same time, if I'll be talking about this single bond, fluorine is more electronegative than hydrogen, so fluorine will get delta delta negative, hydrogen will get plus delta. So fluorine is going to have -1 oxygen state right here, and hydrogen is going to have +1 oxidation state right here, right? Talking about this single bond between nitrogen and hydrogen, nitrogen is more electronegative than hydrogen, so nitrogen will get slight negative, hydrogen will get slight positive. Talking about this single bond, nitrogen again will get slight negative, hydrogen will get slight positive. Talking about this single bond, nitrogen again will get slight negative, hydrogen again will get slight positive. If I'll ask you what is the charge present on this hydrogen right here, what is its oxidation state, you'll say +1, right? +1, right? +1, right? And what about this nitrogen right here? It's going to be -3. So remember guys, whenever hydrogen will be attached to more electronegative element than itself, at that time I'll take the oxidation state of hydrogen as +1 in short. Yes, this was the next rule. Okay. Now people, at the same time, whenever hydrogen will be attached to less electronegative element than itself, whenever hydrogen will be attached to less electronegative element than itself, at that time hydrogen will have -1 oxidation state. Okay, as you can see here, see the statement guys, have a look on the statement. When hydrogen is attached to least electronegative element than itself, its oxidation state will be taken as -1 simply, right? In case of NaH, since hydrogen is more electronegative than sodium, hydrogen over here will be in -1 oxygen state, sodium will be in +1 oxygen state, hydrogen again will be in -1 oxygen state, magnesium will be in +2 oxygen state, right? Magnesium belongs to alkaline earth metals which show +2 oxygen state, sodium belongs to alkali metal which shows +1 oxygen state, right? Yes. Very simple. Now people, at the same time, there are few more important rules which I want you guys to remember right here. Okay, the oxidation state of oxygen is generally taken as -2 when it is attached to less electronegative element than itself. Yes. Very simple. Remember, the oxidation state of oxygen is generally taken as -2 when it is attached to what? When it's attached to less electronegative element than itself. Taking the case of MgO, over here oxygen will have -2 charge, oxygen is attached to less electronegative element. Over here again oxygen will have -2, oxygen is attached to less electronegative element than itself. Over here again oxygen will have -2 charge. So remember, whenever oxygen will be attached to the less electronegative element than itself, you'll be taking the oxidation state of oxygen as -2. Yes, very simple. Okay, now people, there are certain compounds as well in which oxygen shows different oxidation state than this -2 as well. Whenever we talk about peroxides, what are peroxides? Whenever you see a single bond linkage between oxygen and oxygen, this single bond linkage between oxygen and oxygen is what we call as peroxide linkage. It's what we call as peroxide linkage, right? And whenever this peroxide linkage will be present in any compound, at that time oxygen will have -1 oxidation state on it, right? Oxygen will have -1 oxidation state on it. Yes, very simple. For example, if you take the case of hydrogen peroxide, let's say you have got H2O2, which we call as hydrogen peroxide. It has got open book-like structure, as you all must be remembering, but I'm not talking about the structure right here. Okay, I just need to show you how its oxidation state is -1 right here. See guys, it's a very simple case. If I'll first of all talk about this single bond right here between oxygen and hydrogen, oxygen is more electronegative than hydrogen, so oxygen will have I'm not going to represent -delta plus delta now. Okay, I'll be simply writing -1 plus 1, but you should know these are not the actual charges, these are the virtual charges. Yes, very simple. Okay, now people see over here oxygen is more electronegative, so oxygen will have -1, hydrogen will have +1. Yes, due to this bond, oxygen will have -1, hydrogen will have +1. Okay, now people, if I talk about this bond, on one side we have got oxygen, on another side we have got oxygen. Can I say the electron pair will be exactly at the center? If the electron pair is exactly at the center, there'll be no contribution of this bond towards the charge present on any of these oxygen atoms right here. Yes, so very simple, right? Now people, talking about this one, oxygen is more electronegative, so -1 plus 1. Now what is the charge present on the oxygen atom over here? -1 charge. So remember guys, whenever you see a peroxide linkage over here, in case of your hydrogen peroxide, sodium peroxides, rubidium peroxides, whatever peroxide you'll have, at that time oxygen will show -1 oxidation state right here. Yes, very simple. Okay, all right. Now people, there are few more examples as well where oxygen shows different oxidation states. First, Oxygen will show -2 oxygen state when it will be attached to less electronegative element than itself. In case of peroxides, whenever there will be single bonded linkage between oxygen and oxygen, at that time oxygen will have -1 oxygen state. Yes. Now people, in case of superoxides, the oxidation state of oxygen will be -1/2. Superoxide is this one. Whenever you see oxygen in the form of O2 negative, this is what we call as superoxide. This is what we call as superoxide. Yes. For example, you have got sodium superoxides, you have got rubidium superoxides, whatever superoxides you have. Okay. Now people, first of all, on two oxygen atoms, charge is -1. On one oxygen atom, charge will be simply -1/2, and the charge present on an atom the charge present on an element in a compound is what we call as oxidation state. So I would say the oxygen over here has got the charge -1 on it. So I would say -1/2 is going to be its oxidation state. Very, very, very simple. Yes. So in case of superoxides, there will be -1/2 oxidation state. There will be -1/2 charge present on it. Yes. Taha abhi samajh aayega. Wait for it. Okay. Yes. Janan, you can take you can take this compound. You can take your sodium peroxide. Yes, you can take your sodium peroxide where the oxygen state of oxygen will be -1. Okay, this again the example of the peroxide. Yes. Simply in case of superoxides, the oxidation state will be -1/2. Correct? Now people, there are few more examples as well. Now if I talk about the oxyfluorides, if I talk about OF2 or O2F2, these are the only two compounds of oxygen where oxygen shows positive oxidation state. Okay? For example, if I talk about OF2 structure is like this. This is the structure of OF2. And what about the structure of O2F2? This is the structure of O2F2. Yes, this is the structure of O2F2. These are the only two compounds where the oxygen shows positive oxidation states. Yes. Now people, first thing, if I consider this single bond right here, oxygen is more electronegative, so -1, fluorine plus, sorry. On other side we have got fluorine. Yes, fluorine is more electronegative than oxygen. If fluorine is more electronegative than oxygen, fluorine gets -1 charge, oxygen gets +1 charge. At the same time, due to this single bond, fluorine is more electronegative, so -1 +1. What is the charge present on this oxygen right here? I would say +2, which is going to be the oxidation state of oxygen right here in this compound. Yes. All right. Okay, talking about this one, guys. If I talk about this single bond between oxygen and fluorine is more electronegative, so -1 and +1. Okay. Due to this single bond, will there be any charge present on the atoms? Due to this single bond, no way, because on both the sides we have got same atoms, so electron pair is exactly going to be at the center. Now, if I talk about this single bond, fluorine is more electronegative, so fluorine will have -1, oxygen will have +1. So oxygen right here is having +1 oxygen state. Okay. In both the atoms, oxygen is showing +1 oxygen state right here. So remember, these are the only two compounds where the oxygen shows positive oxidation states. In case of OF2, it shows the oxidation state of +2. In case of O2F2, it shows the oxidation state of +1. Yes, very, very, very simple. Correct? Now people, talking about few more things. The oxidation states of halogen. The oxidation state of halogen. Halogen means group 17 elements. Yes, the oxidation state of halogen generally is -1 when halogen is attached to less electronegative element than itself. Yes, as in case of HCl, chlorine has got -1 charge. In case of HF, fluorine has got -1, bromine has got -1 over here. So whenever halogen will be attached to less electronegative element than itself, yes, at that time it will have the oxidation state of -1 right here. Yes. Yes, Dawn Gamer, oxidation state is calculated. Wait for it. Yes. All right. Now we will see. Whenever halogen will be attached to more electronegative element than it, then definitely halogen is going to show the positive oxidation state, right? First of all, if I'll take the case of Cl2, let's say this is your Cl2 right here. Yes, due to this single bond, guys, oxygen is more electronegative than chlorine. Oxygen will have -1, chlorine will have +1. Due to this single bond, again oxygen will have -1, chlorine will have +1. So over here here you can see the halogens are showing +1 oxygen state right here. So remember, halogen when attached to more electronegative element than itself, its oxygen state will be taken as +1. Similarly, in case of ClF3, I'm making the rough structure of ClF3. This is the roughly structure of ClF3, for example, correct? Fluorine is more electronegative than chlorine, so fluorine will have -1, chlorine will have +1. Due to this single bond, fluorine -1, chlorine +1. Due to this single bond, fluorine -1, chlorine +1. What is the charge present on this chlorine in total? I would say +3. So this is the compound in which the halogen chlorine is showing +3 oxygen state. So whenever halogen is attached to more electronegative element than itself, it's called as what? I mean, its oxygen state will be positive. Or you take the case of what? Interhalogens, right? This was my first interhalogen. Now, second interhalogen is IF5, right? This is what we call as, these two compounds are what I call as interhalogen compounds. When the elements of the halogens, they intermix and form a new compound, those compounds which get formed, those are what we call as interhalogen compounds. Yes. For example, in case of IF7, iodine is going to have +7 oxygen state. So this is also one compound in which the halogen is showing positive oxygen state. Now, people remember, fluorine is the most electronegative element in the periodic table. So fluorine will be always showing -1 oxygen state. There is no element in the periodic table whose electronegativity is more than that of fluorine. So fluorine is the element whose electronegativity is maximum. So fluorine will always show -1 oxidation state. I'm sure this is clear to everyone till here. Now we will talking about few more things. There is something called as the radicals. What are radicals? Radicals are the atoms or group of atoms which have got some charge on them. Radicals are the atoms or group of atoms which have got some charge on them, right? And people, radicals are considered as a single unit. And whatever is the charge present on the radical, that charge is taken as the oxidation state of that radical. What do we mean by that? Tech games, I have talked about superoxide, bro. You just watch the replay of the video, you'll get to know what are superoxides, right? Okay, see guys, understand. These are the common examples of the radicals. I told you radicals are the atoms or group of atoms which have got charge on them, right? First of all, if I'll talk about halides are the halogens having negative charge on them. These are what we call as halides. So any atom or group of atom having charge on them, that's what we call as radical. And radical is considered as a single unit, and whatever is the charge present on it, that's going to be the oxidation state of that radical, right? See guys, the charge present on this fluorine right here is -1, chlorine -1, bromine -1, iodine -1. So their oxidation state will be -1 right here. Yes. Similarly, O dinegative, this is what we call as oxide. Charge present on it is -2, its oxidation state will be -2. N trinegative, oxidation state -3. P trinegative, oxidation state -3. S dinegative, oxidation state -2. Yes, there are few more radicals, guys, which you need to remember. See, this is not the atom, this is the group of atoms having charge on it. And what is the charge present on this OH right here? It is -1. -1 is the charge present on this OH. So I'm going to consider this OH as a single unit. This is my radical. Radical is considered as a single unit. And whatever is the charge present on it, that's going to be its oxidation state. So I would say the oxidation state of OH right here is simply -1. Talking about the cyanide, right? Cn -1. Yes, I would say this is my radical. This is the group of atoms having charge on it. This is the group of atoms having charge on it. I'll be calling it as the radical. And whatever is the charge present on the radical, that's going to be the oxidation state of the radical. So oxidation state of radical right here is -1. Yes. Similarly, oxidation state of NC negative right here is -1. Similarly, we have got SO4 negative. It's again considered as a radical. Its charge is -2. So its oxidation state will be -2. Oxidation state of SO3 right here will be simply -2. Yes. So whatever is the charge present on the radical, that charge is taken to be the oxidation state of that radical in short. Yes, Jen, exactly. All right, talking about, guys, few more radicals we have got PO4 trinegative, which we call as phosphate. Charge present on it is -3. So -3 will be the oxidation state of this phosphate right here. Correct? Because radical, it's considered as a single unit, and whatever is the charge present on it, that's going to be its oxidation state. Similarly, PO3 trinegative, which is what we call as phosphate, right? -3 will be the oxidation state of it. Similarly, oxalate ion we have -2 charge on it. So oxalate ion will be taken as a single unit. Its oxidation state will be taken as -2. Similarly, we have got thiosulfate. Its oxidation state is -2. Similarly, we have got tetrathionate. Its oxidation state is what? Its oxidation state is -2 right here. Yes, very simple. Now people, why am I telling you all this? Why am I telling you all this? We have got few more over here. NH4 positive, which is what we call as ammonium ion. This is a group of atoms having charge on it. I'll be calling it as a radical. So this radical has got +1 charge on it. So +1 will be called as the oxidation state of this radical right here. Similarly, +1 is going to be called as the oxidation state of this radical as well. NH4 positive is called what we call as ammonium ion, and NO positive is what we call as nitrosyl ion. Correct? Now people, something which I want you guys to remember right here. The sum of the oxidation states of all the elements present in a molecule is equal to net charge present on it. If you got to know this rule, you can easily calculate oxidation state of any element in a compound. Yes. Let me know in the chat box if it's clear till here, so that I can move on and I can show you how to calculate oxidation states of different elements through the rule which I showed you at the end. Let me know in the chat box, guys. Let me know in the chat box if everything's clear till here. Yes. Oh, my throat is getting dry. All right, it's okay, Hari, it's okay. All right, guys, understand one thing. See, I have underlined few elements right here. I need to calculate their oxidation states. How do I do that? First of all, I have got Cr2O7 dinegative. Yes, I have got Cr2O7 dinegative. If I'll ask you, what is the net charge present on this over here? The net charge present on this is -2. What is the net charge present on this right here? It is -2. What is the net charge present on this NH4 over here? It is +1. What is the net charge present on this ClO4 this is -1. What is the net charge present on this over here? It is -2. Yes, very simple. First of all, if I want to calculate the oxidation state of chromium right here, see guys, understand. Let's assume the oxidation state of chromium is X. And how many chromium atoms do we have? We have 2 chromium atoms, so I'm multiplying this X by 2. Yes. Now people, at the same time, we have got oxygen right here, and normally oxygen shows which oxygen state? It shows -2 oxygen state. And how many oxygen atoms do we have? We have got 7 oxygen atoms, right? Is equal. What is the net charge present on this molecule? It is -2 over here. People, if you'll calculate the value, you'll get the value of X over here as +6. Yes, and what is X? X is the oxidation state of chromium right here. So oxidation state of chromium right here in this compound is +6. Yes. Simple. Talking about the second case, guys, S2O3 dinegative. Let's assume the oxidation state of sulfur as X. And how many sulfur atoms do we have? We have got 2 sulfur atoms, right? Oxidation state of oxygen, as you all must be knowing, it is -2. And how many oxygens do we have? We have got 3 oxygens, right? What is the net charge present on it? Net charge is -2 over here. So isn't it going to be 2x minus 6 is equal to -2? Isn't it going to be 2x is equal to +4? Isn't it going to be x is equal to +2? And what was x? X was the oxidation state of sulfur over here, which is +2. Yes, very simple. Yes, is it clear to everyone? Talking about this NH4 positive. Let's assume the oxidation state of nitrogen is X, and how many nitrogen atoms? Only 1, right? Plus hydrogen will have +1 oxygen state, correct? And how many hydrogen do we have? 4. What is the net charge present on this molecule? It is +1. Yes, so it's going to be X is equal to +1 minus 4. Value will be -3. So nitrogen will have the oxygen state of -3 right here. Nitrogen will have the oxygen state of -3 right here. Yes, nitrogen will have -3 oxygen state right here. Similarly, if I talk about this chlorine right here, this is X, okay, plus oxygen will have -2. How many oxygen atoms? 4 oxygen atoms. What is the net charge present on it? -1. So X value will be coming as +7. So +7 is the oxidation state of chlorine right here. Right? Similarly, if I talk about CrO4 dinegative, let's take the oxidation state of chromium as X, right? Apart from this, we have got oxygen as well. What is the oxidation state of oxygen? It is -2. And how many oxygens do we have? We have got 4 oxygens, right? Net charge present on is -2. So it's going to be X minus 8. X minus 8 is equal to -2. So X value will be +6. Yes, these are the simple rules by means of which we can calculate the oxidation state of any element in a compound. Yes, I'm sure this is clear to everyone. I'm moving on and talking about few more compounds right here. First of all, let me talk about Fe2O3. Let's calculate the oxidation state of iron right here. Let's assume the oxidation state of iron is X, and how many iron do we have? We have got 2 iron atoms. Apart from this, we have got oxygen as well. What is the oxidation state of oxygen? It is -2. And how many oxygens do we have? We have got 3 oxygens. What is the net charge present on it? There is no net charge present on it, right? So I'll say 2x minus 6. 2x minus 6 is 0. So x value will be coming as +3. So over here, iron is having the +3 oxidation state. Yes? Very simple. Now people, what about the oxidation of iron right here? Isn't it going to be 3x minus 8 is equal to 0? Isn't it coming as x is equal to +8/3? So over here, oxidation state of iron is coming as fractional +8/3. That is the reason why this oxidation state of iron comes as fractional, which I'll be letting you know in the next session when I'll be teaching you the average oxidation state. Yeah. Now people, in case of FeCN6 trinegative, let's assume the oxidation state of iron as X. Now people, this CN, cyanide is causing, it's considered as a radical. It is a radical, and whatever is the charge present on the radical, that is going to be the oxidation state of radical, right? Cn will be having -1 charge on it. And how many Cn do we have? We have got 6 Cn right here. What is the net charge present on this compound? It's -3. So x value you'll be getting as +3. So iron right here is in +3 oxidation state. Now talking about this carbonyl group, guys, this carbonyl is a neutral one. It is a neutral one. There is no charge present on it. So in case of nickel, in case of NiCO5, there is no charge present on this nickel, right? In case of H2SO4, again there will be +6 oxidation instead of this sulfur. You can calculate it. +1 into 2 plus x plus -2 into 4 is equal to 0. You'll get the value of x over here as +6. I'm sure this is clear to everyone. Now people, there are few more interesting things which you need to remember right here. Okay, talking about this, guys, talking about this NH4NO2. In order to calculate the oxidation state of both these nitrogens right here, what I'll be doing, first of all, let me tell you, this compound, it exists in the form of NH4 positive, NH4 positive and NO2 negative. It exists in the form of NH4 positive, NO2 negative, right? So people, there are two nitrogens basically. There are two nitrogens basically. What is the oxidation state of this nitrogen over here? What is the oxidation state of this first nitrogen over here? I'll assume the oxidation state of nitrogen is X. How many nitrogen we have right here? We have got 1 nitrogen. Talking about hydrogen, we'll have +1 oxidation state. How many hydrogens do we have? 4. What is the net charge present on it? +1. So x value over here you'll be getting as +3. +3 or -3? Sorry, it's -3, yeah? So this nitrogen will be present in -3 oxidation state. Now talking about this nitrogen, let's assume the oxidation state of this nitrogen is X. Let's take the oxidation state of oxygen as -2. And how many oxygens do we have? 2 oxygens. What is the net charge? -1. So X value will be coming as +3. X value will be coming as +3. So oxidation state of this nitrogen is coming as +3. Oxidation state of this nitrogen is coming as -3, right? Now people, at the same time, Ki3 negative. What is the oxidation state of iodine in case of Ki3 negative? Can I say potassium, it belongs to the group first elements, and group first elements, they show +1 oxidation state, right? Now plus, let's assume the oxidation state of iodine as X, and how many iodines do we have? We have got 3 iodines. Is there any net charge present on this molecule? No way. So X value right here will be getting as -1/3. So -1/3 is the oxidation state of iodine right here. Why this oxidation state comes as fractional? This is something which we have to discuss in detail in the next session, right? Just I wanted you to show how to calculate oxidation states of different elements in a given compound over here, correct? Now people, I'm giving you one question. You tell me, what is the oxidation state of chromium in CrO5? What is the oxidation state of chromium in CrO5? I'm waiting for your answers. Till then, I can have some water. Tell me, guys, what is the oxidation state of chromium right here in this compound? Yes? Tell me fast. I'm waiting for your answers. I'm waiting for your answers. Tell me fast, tell me fast. Tell me fast. अभी इस बॉटल से कुछ नहीं पीता हूँ यार, इसमें पानी गर्म रहता है बस. It is good for the throat, that's it. Because अगर ठंडा पानी पीऊंगा तो गला बैठ जाएगा पूरा. See, a lot of people are saying +10, a lot of people are saying +6. So who to believe? Who to believe? Okay, it's a very simple thing, guys. Okay, see, if I'll assume the oxidation state of chromium as X, correct? Oxygen will show -2. How many oxygen atoms? 5 oxygen atoms. Net charge is 0. So X value will be +10. X value will be +10. If you get this answer, that will be wrong. That will be wrong. Remember, guys, remember. Make it a note. Make it a note. Make it a note of it, okay? See guys, the oxidation state, I'm writing a note over here, the oxidation state of an element, the oxidation state, or let me write it like this, the maximum oxidation state, oxidation state of an element cannot be greater than +7 except osmium in OSO4. Except osmium in OSO4. Whenever guys, by using the formula, you get to see that the oxidation state is coming as greater than +7. Except osmium, where it is +8 over here in this compound. Leave this compound. This is the exception. This is the exception. I've got nothing to do with this. Wherever you see the oxidation state of element coming out to be greater than +7, at that time, remember, at that time we have to consult the structure. At that time, we have to consult the structure of the molecule. Yes. So over here, guys, over here in case of CrO5, by using the formula, it's coming as +10. It's coming as +10. Is +10 possible? +10 is not possible. Why? I have made a note out of it. I've made a note right here. I've told you the oxidation state of an element, the maximum oxidation state of element can be +7, except osmium in case of OSO4. Wherever you get to see the oxidation state of an element coming out to be greater than +7 by using the formula, that means at that time I'll have to consult the structure. Otherwise, we cannot do that. Otherwise, we won't be able to get that. Yes? Yes? Now people understand. See. Now people understand. There are few molecules whose structure you need to understand. Whose structure you need to remember, okay? See how I'll be making the structures, and people, whatever structures I'll be giving you right here, I want all of you to try those structures twice, 3 times so that you can remember them, okay? Because those are really, really very important, right? Okay, let's get to know the structures of different elements, right? First of all, we have got CrO5. CrO5, guys, let me tell you, it has got a butterfly structure. And let me tell you at the same time, it is deep blue in color. Right? Talking about the structure of CrO5, how its structure looks like. It looks like a butterfly, guys. It looks like a butterfly. It's like this, okay? It looks like a butterfly. This oxygen, right? This is the structure of CrO5. Now, people, let me show you how do we calculate the oxidation state by means of a structure. Yes? Yes, understand guys, understand. If I'll talk about this bond, this single bond between chromium and oxygen, I'll say oxygen is more electronegative than chromium. Oxygen will have -1 charge on it, chromium will have +1 charge on it, right? Due to the electronegativity difference, the bonded pair will be slightly shifted towards oxygen, so electron density will be more towards oxygen, due to which oxygen gets -1 charge, chromium gets +1 charge due to this bond, right? Talking about the second bond right here, guys, oxygen is again more electronegative, so oxygen -1, chromium +1. What about this single bond? Oxygen -1, chromium +1. What about this single bond? Oxygen -1, chromium +1. Now over here we have got double bond, right? Due to this double bond, oxygen -2, chromium +2. People, is this bond going to make any difference? No way. It's a peroxide linkage. Single bond between oxygen and oxygen. This is a peroxide linkage. Again, this is a peroxide linkage. So there are 2 peroxide linkages in case of what? In case of CrO5, which we were neglecting while calculating the oxidation state of chromium as per formula. Yes, as per formula, I was taking all the oxygen atoms to be in -1 oxygen state, but I forgot in the structure there are 2 peroxide linkages where 4 atoms of oxygen will be in -1 oxygen state. Yes? Yes? Yes, very, very simple. Now people see. If I'll ask you what is the net charge present on this chromium right here, it's going to be +2, +1, +1, +1, +1. Isn't it going to be +6? Yes. From the formula, it was coming as +10, but we got to know from the structure, it is +6. Hit the like button if you got it. Hit the like button of the video if you got it, so that I can move on and give you few more structures. Give on. Tell me fast. Yes, Janan, you can see in peroxide is -1, right? It's -1. Yes, everywhere it's -1. Wherever it's forming peroxide, wherever there is peroxide linkage, it's showing -1 oxygen state, yeah? All right, people, let's move on to one more structure. I'm sure this is clear to everyone. The another structure which I'm going to make over here, that's H2SO5, which is what we call as Caro's acid, okay? How its structure looks like, how the structure of Caro's acid looks like. Have a look, guys. See, this is S double bond O, this is S double bond O. We have to make what? H2SO5 we need to make, right? This S double bond O, this is oxygen, with this oxygen, hydrogen is attached, and over here, we have got a peroxide linkage between oxygen and oxygen. This is the peroxide linkage between oxygen and oxygen. Let me make it with a different color. This is the peroxide linkage between oxygen and oxygen. Yes, this is the structure of H2S1, 2, 3, 4, 5. Yes, now people, you can calculate the oxygen state by means of the structure. Yes, understand, guys, understand properly. If I'll talk about this double bond between sulfur and oxygen, oxygen is more electronegative than sulfur. Due to this double bond, oxygen will get -2 charge, sulfur will get +2 charge. Now people, talking about this double bond between oxygen and sulfur, oxygen is more electronegative, so oxygen again will have -2 due to this double bond, and sulfur at the same time will have +2 charge due to the double bond. Yes, talking about this single bond right here between sulfur and oxygen, oxygen will have -1 charge, sulfur will have +1 charge. Talking about this single bond, oxygen will have -1, sulfur will have +1, because oxygen is more electronegative. Now people, if I ask you what is the net charge present on this sulfur right here, +2, +3, +5, +6. So sulfur over here again is in +6 oxygen state. So remember this structure at the same time. Yes, very, very, very simple. Okay, right? Moving on. I'm moving on to one more structure, guys. Let's talk about few more structures. We have got Marshall's acid, H2S2O8. H2S2O8. How its structure looks like. See, guys, how its structure look like. H2S2O8. This is going to be oxygen. With this oxygen, hydrogen is attached. There we have got two oxygens over here. This S double bond O, this oxygen, this is hydrogen. This is the structure of H2S2O8. Understand, guys, I need to calculate the oxidation states of both these sulfur atoms. This sulfur atom and this sulfur atom, right? You can calculate it by using the structure. I have given you the structure. You can easily do that. First of all, if I'm considering this single bond, oxygen is more electronegative than sulfur. So oxygen will have -1 charge due to this single bond. Sulfur will have +1 charge. Due to this single bond, oxygen will again have -1, sulfur will have +1. Due to this double bond, oxygen will have -2, sulfur at the same time will have +2. Due to this double bond, oxygen will have -2, sulfur will have +2. If I'll ask you what is the net charge present on this sulfur, is it going to be +6? Yes, +2, +2, +4, +5, +6. Oxygen state of this sulfur right here is +6. Yes, what about the oxygen state of this sulfur, guys? Due to this double bond between sulfur and oxygen, oxygen is more electronegative, so oxygen will have -2, sulfur will have +2. Due to this single bond, oxygen will have -1, sulfur will have +1. Due to this double bond, oxygen will have -2, sulfur will have +2. Due to this single bond, oxygen -1, sulfur +1. What is the net charge present on this sulfur right here? It's again +6. Yes, +6 on first sulfur, +6 on second sulfur. If I'll ask you what is the net average oxygen state of sulfur, it's going to be +6 divided by number of sulfur atoms, 2. So +6 is going to be the average oxygen state of the sulfur right here. Okay, moving on to few more compounds. We have got S4O6 dinegative. People, this question was once asked in your JEE Advanced. The question was like this. The question was like this. The correct set of oxidation state of sulfur is. You were given with few options. I think options were given like this. +5, 0, 0, right? Option B was given as +5, 0, 0, +5. Option C was given as this was 0, 0, +5 and +5, and option D was none of the above. If you do not know the structure of this S4O6 dinegative, you can never answer this question. Yes? 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 See, guys, understand. If I draw the structure of S4O6 dinegative, the structure is going to be S double bond O, this is double bond O, this is oxygen with a negative charge on this oxygen, this is sulfur, this is sulfur, this is sulfur, this is double bond O, this is double bond O, this is oxygen, negative charge on this oxygen, right? I need to calculate the oxidation state on sulfur. Okay, Mehreen is saying it's B, Yashwant is saying it's B. Wonderful, great, great, great. All right, let's try it out. First of all, if I'll consider this single bond between sulfur and oxygen, oxygen is more electronegative, so -1, sulfur +1 due to this single bond. If I'm considering this double bond, oxygen will be -2, sulfur will be having +2. If I'm considering this double bond, oxygen is more electronegative, so oxygen will have -2 due to the double bond, sulfur will have +2 due to the double bond. People, will this bond make any difference? No way, because on both the sides we have sulfur, right? On both the sides we have got sulfur, so there is 0 oxygen state on this, there is 0 charge, 0 oxygen state on this. Now people, talking about this double bond, oxygen is more electronegative, so minus 2, sulfur plus 2. Due to this double bond, oxygen minus 2, at the same time sulfur plus 2. Due to this single bond, oxygen minus 1, sulfur plus 1. Now calculate the oxygen state of each sulfur atom right here. You can easily do that. Now people see the oxygen state of sulfur right here is plus 5. The oxygen state of sulfur right here is 0. The oxygen state of sulfur right here is 0. The oxygen state of sulfur right here is plus 5. So correct set of oxygen state of sulfur is going to be plus 5, 0, 0, plus 5. Hit the like button. Let me know if you got the concept right here or not. Yes. Janan, it's going to be plus 1 in Marshall's acid. Right? Okay, moving on to a few more structures, guys. Moving on to a few more structures. We have got bleaching powder, right? Bleaching powder is what we call as CaCl2. CaCl2 is what we call as bleaching powder. What is its structure? People, if I'll ask you to calculate the oxidation state of chlorine right here by using formula, can you do that? Absolutely. If I want you guys to calculate the oxidation state of chlorine right here by means of formula, we can do that. Yes. So I'll say calcium right here will be present in plus 2 oxygen state. Why? Because calcium belongs to alkaline earth metals. Yes. Oxygen will be simply present in minus 2 oxygen state. Let's assume the oxidation state of chlorine is x, so it's going to be 2x. Net charge present on is 0, so x value over here is coming as 0. What does that mean? Does that mean there is no charge present on this chlorine? Does that mean there is no charge present on this chlorine? Okay, see people, see, if I make the structure of this bleaching powder, it's going to be CaOCl, and over here it's going to be Cl. Now people, if I have drawn the structure, now you can calculate the oxidation state of each element right here. This is single bond, oxygen is more electronegative than chlorine, so due to this bond, oxygen will be having minus 1, chlorine will be having plus 1. Due to this single bond, oxygen more electronegative, calcium less electronegative, so oxygen will be having minus 1, calcium will be having plus 1. At the same time, due to this single bond, chlorine more electronegative, so minus 1, calcium plus 1. What is the net charge present on this calcium? Net charge present on this calcium is plus 2. What is the net charge present on this oxygen? It is minus 2. What is the net charge present on this chlorine? It is minus 1. What about this chlorine? It is plus 1. Okay, over here we got the value of x as 0. Does that mean there is no charge present on chlorine? There are charges present on chlorine, but the charges are equal and opposite. So I have got over here the average oxygen state. This is the value of average oxygen state of chlorine right here. Plus 1 minus 1 divided by 2. Yes? Yes? Does that mean there is no charge present on chlorine? Chlorine have got the charges, but both the charges are equal and opposite right here. Yes? Yes? All right. Moving on to a few more. Okay, we have got structure of BaSCN whole twice. People remember this structure as well, because I'm going to use this structure when I'll be teaching you n factor calculation and titration in this chapter only. Okay? Understand over here. BaSCN whole twice. The structure will be like this. Ba, this is S, this is C, triple bond N, this is BaS, this is C, this is triple bond N. Now people understand how to get the oxygen state right here. Due to this triple bond, I'll say nitrogen is more electronegative than carbon. So due to this triple bond, nitrogen will have minus 3, carbon will have plus 3. Due to this triple bond, again nitrogen will have minus 3, carbon will have plus 3, right? Because nitrogen is more electronegative than carbon. Yes, absolutely. Now people talking about this single bond. Let me tell you, sulfur is more electronegative than carbon. So sulfur will be having minus 1, carbon will be having plus 1. Sulfur will be having minus 1, carbon will be having plus 1. Now people, due to this single bond, sulfur is more electronegative due to this barium. So sulfur due to this bond minus 1, barium plus 1. Sulfur due to this single bond minus 1, barium plus 1. If I'll ask you what is the net charge present on this Ba right here, you should say plus 2. If I'll ask you what is the net charge present on this sulfur over here, it's going to be minus 2. If I'll ask you what is the net charge present on this sulfur right here, it is minus 2. If I'll ask you what is the net charge present on this carbon right here, isn't it plus 4? Absolutely, plus 3, plus 1, plus 4. What about this carbon? It's going to be plus 4. What about this nitrogen? It's going to be minus 3. What about this nitrogen? It's going to be minus 3. So you got the charges on all the elements. You got the oxidation states of all the elements right here. Yes? Janan, that is the average oxidation state which comes out to be 0 for chlorine in the bleaching powder, right? Yes? All right. Moving on to a few more structures, guys. Okay, H2SO4, you can make the structure. Yes, you can make the structure. This will be your homework. Okay, you make it structure. Send me the photo of that structure in my Instagram, Telegram, wherever you see me. Okay, moving on. Yes, Karthik, you can do that. You can do that. Why not? All right. Now, people, there are few acids of phosphorus whose structures you need to remember, because I'm going to use those structures while teaching the N factors, okay? See, guys, first thing, I'm writing over here H3PO2, H3PO2. Then I'm writing H3PO3. H3PO3. Let me show you all these structures in the single slide. H3PO2, H3PO3. Then I'm writing H3PO4, and at the same time I'm writing H3PO5. Yes, these are some acids of phosphorus which I'm writing over here. Yes. Now we will see H3PO2. H3PO2 structure, let me show you like this. First of all, make a double bond between phosphorus and oxygen. In this compound, make a double bond between phosphorus and oxygen. In this compound, make a double bond between phosphorus and oxygen. In this compound, make a double bond between phosphorus and oxygen. Yes. How many oxygens are left? One oxygen is left. So one oxygen, and with this oxygen we have got hydrogen. Since we have got three hydrogens, so one hydrogen here, one hydrogen here. This is the structure of H3PO2. Talking about the structure of H3PO3, it's going to be like this: oxygen, this hydrogen, this oxygen, this hydrogen, and this is hydrogen attached directly to phosphorus. Yes. In case of H3PO4, the structure is going to be like this. The structure is going to be like this. I want all of you to make a note of it fast. Yes, this is the structure of it. In case of H3PO5, isn't it going to be like this? Oxygen, hydrogen, this is oxygen, hydrogen, this is oxygen peroxide linkage, this one more hydrogen. Yes, these are some acids of phosphorus which I want you guys to take a note of. Talking about the oxidation state of phosphorus everywhere, due to this double bond, oxygen is more electronegative than phosphorus, so oxygen will have -2 charge, phosphorus will have +2 charge. Due to this single bond between phosphorus and hydrogen, phosphorus is more electronegative than hydrogen, so phosphorus -1, hydrogen +1. Phosphorus is more electronegative than hydrogen, so phosphorus -1, hydrogen +1. Due to this single bond, oxygen is more electronegative than phosphorus, so oxygen -1, phosphorus +1. What is the net charge present on this phosphorus right now? This is +2 +1, that means +3, +3 -2 means +1. So +1 is the oxidation state of phosphorus right here in this compound. Yes. Now people, at the same time in this compound, due to this double bond, oxygen is more electronegative, so -2, phosphorus +2. Due to this single bond, phosphorus is more electronegative, so -1 +1. Oxygen is more electronegative, -1 +1. Oxygen is more electronegative, -1 +1. If I'll ask you what is the net charge present on this phosphorus right here, you should say +2, +3, +4, -1, that means +3. +3 is the oxidation state of phosphorus right here. Now people, talking about this structure, if I'm considering this double bond between phosphorus and oxygen is more electronegative, so -2, phosphorus +2. Due to this single bond, this is -1, due to +1. Due to this single bond, again -1, +1. Due to this single bond, -1, +1. So what is the net charge present on this phosphorus right now? +2, +3, +4, +5. So +1 is the oxidation state of phosphorus right here. Now in case of H3PO5, again it's going to be what? Again it's going to be +5. Yes, these were 5 structures which I want you guys to take a note of, because I'm going to use these structures directly in the In the N factor calculation. Yeah. No, Yashwini, I haven't ordered the glasses yet. I'll order them soon. I forget every day. Yeah. Yes. Okay, let me see if there are few more structures left. Okay, one last structure, guys, K3CrO8. Okay, it has got a typical structure. This is Cr, this is single bond, this is single bond, this is oxygen, this is oxygen, this is oxygen, this is oxygen, a peroxide linkage, peroxide linkage, peroxide linkage, this is potassium, this is potassium, this is potassium, right? Now people, anything can be asked. If you know the structure, anything can be asked. You can be asked like this: how many oxygen atoms are there in this compound with -1 oxygen state? You can be asked how many peroxide linkages are here. You can be asked what is the oxidation of chromium right here. Yes. Yes. Now people, understand what I'll be doing. See, first of all, if I'm considering this single bond between chromium and oxygen is more electronegative, so oxygen will have -1 charge, chromium will have +1 charge. Due to this single bond, oxygen is more electronegative. Yes, so oxygen -1, chromium +1 due to this single bond. What about this single bond? Will it make any difference? No, it's a peroxide linkage. It's not going to make any difference right here. Yes. Now people, see, if I'll talk about this single bond, oxygen is more electronegative, so oxygen -1, chromium +1. Due to this single bond, oxygen -1, chromium +1. Due to this single bond, -1 +1. Will this bond make any difference? No way. Will this bond make any difference? No way. Will this bond make any difference? No way. Why? Because these are peroxide linkages, right? Now people, talking about this single bond right here, oxygen is more electronegative than potassium, so oxygen -1, potassium +1. What about this single bond? -1 +1. What about this single bond? -1 +1. So people, you got the charge on each element right here. You got the oxidation state of each element right here. So people, oxidation state of this oxygen is -1, this oxygen is -1, chromium you got as +1, +1, +1, +1, +1, that means +5. This oxygen you got as -1. This oxygen state is -1. This oxygen -1. Every oxygen is present in -1 oxygen state. Now people, if the question is asked, how many oxygen atoms do we have in this structure with -1 oxygen state, you should say there are 8 oxygen atoms in this structure with -1 oxygen state. If you are asked how many peroxide linkage do we have here, this is 1 peroxide linkage, 2nd, 3rd, 4th. So there are 4 peroxide linkage at the same time in this structure. I want all of you to remember these structures. These are really, really very important. Yes, yes, yes. Janan, you have to try these, bro. Otherwise, you are not going to, Asan, I've drawn the H3PO3 structure. If you remember, H3PO3 structure was like this. Yes, P double bond O. Yeah, this oxygen, this hydrogen. Yes, this is oxygen, this is hydrogen. This is the structure. Oh, H3PO3. This is the H3PO3 structure. Yes, this is the H3PO3 structure. Yeah. We have drawn this structure, H3PO3, correct? Yes? Okay. All right, guys. So this was all from my side, okay? So if you have any sort of doubt, do let me know fast. Yes? Hi, Shakir. How are you doing? You can let me know if you have any sort of doubt here, guys. Well, in the tomorrow's session, we are going to talk about there is one topic left from the ionic equilibrium part, that is the solubility and solubility product, which is important one. So do not miss that topic at all, because tomorrow I'll just give you the brief idea of solubility and solubility product. Then only and only we are going to solve problems in the tomorrow's session. Yes? Yes? And day after tomorrow, we'll start with the n factor calculations right here. And I'm going to take your n factor calculations till your advanced level for sure. Yes? Yes, absolutely. So all right, guys, this was all from my side. Now talking about the NEET 2021 crash course, which we have started. If you guys are interested, you can join it. If you want to get personally trained by us in your physics, chemistry and biology, you can join the crash course. And on this crash course, you have got the discount as well. So if we are going to cover your whole syllabus in this crash course in the actual Vedantu platform, so do give it a try. Do give it a try, because I'm telling you, it's going to be helpful for your NEET 2021. Yeah. And how to get enrolled in it, guys? There's a link in the description box for this crash course as well. Click on that link, use the coupon code as WSNEET. On using this coupon code of WSNEET, you guys are going to get the 2000 discount right here. Okay, and people, on every Monday we start a new batch for the NEET crash course. Yes, on every Mondays we start a new batch for the crash course. Yes. All right, there is one more link. Guys, there is one more link in the description box, which is for the Telegram. So do click on that link as well. Get added in the Telegram group, okay, and stay updated about the classes as well, right? And please do like the video, share and subscribe the channel at the same time, so that everyone will get benefited out of these sessions right here. Okay, so do that. This was all from my side in the today's session. I'm going to see you guys tomorrow again at 11 with one more energetic session, in which we are going to talk about a lot of important and interesting, fascinating things from the topic, which is what we call as solubility and solubility product. Yes, chalo, take care, bye bye, God bless you all and love you all. Take care, guys, take care, bye bye.